So section, excuse me, section 1.7 is interval notation and inequalities. So intervals, x is less than 7, x is less than 7. A lot of people read this as x is less than 7 and 7 is greater than x. But the thing is, psychologically, what you care about is where is x. You know where 7 is. So it makes more sense psychologically to read from the thing you don't know. So since the little end of the arrow is on the x, on both cases, you read x is less than 7. It's kind of important to understand. Now when you graph these, x is less than 7, you have to go by what it says. You don't have a rule, there's no rule that says, oh, x is on the left of 7, therefore the solutions x are to the left of 7. That's wrong. See, because here x is to the right of 7, but it has the same graph where the points x are to the left of 7 on the number line, because it's always the smaller number goes to the left. Okay. This one here, I used a open dot. Open dot is because there's no equals there. It's not less than or equal to. So 7 is not less than 7. So this point 7 is not in this set, because this is only the x's that are less than 7, not the ones that are equal to 7. So there's an open dot there. A parenthesis here means the same thing as an open dot. The advantage to the parenthesis is it looks like when you write it in interval notation, you'll have a parenthesis here rather than an open dot. The advantage to open dot is sometimes you put the open dot in before you know which side to shade. And when you put in parenthesis, you're kind of saying that you're going to shade the left on this parenthesis. See, so they're both useful. And sometimes I even use both at the same time. I'll draw an open circle and then parentheses going both ways. We'll see that later. Anyway, those both mean the exact same thing. And then in interval notation, you always read left to right. Never read right to left. On the number line, you're reading left to right. So you start with negative infinity, which is that left arrow, comma 7. Not 7, comma negative infinity. Negative infinity is never on the right. It's a left arrow. It can't be on the right-hand side. Okay, so negative infinity, comma 7. Why does negative infinity get parentheses? Because negative 7 is not a real... why does negative infinity get parentheses? Because negative infinity is not a real number, so it can't be in the solution set. And parentheses are for endpoints that are not in the solution set. Okay, now let's do the same thing but with equal. So x is less than or equal to 7. X is less than or equal to 7. So we draw the number line, there's 7, and we shade in less than or equal to it. Now we have a solid dot here. Because 7 is less than or equal to 7, it's equal to 7. And the solid dot corresponds with this square bracket. Okay, and again, this arrow to the left corresponds to negative infinity. So if we write out interval notation for that, we get negative infinity, comma 7. We're still reading left to right on the number line. But now, since negative infinity is not a real number, it can't be a solution. So it's in parentheses, as before. But now 7 is a solution because 7 equals 7 satisfies this inequality. So it's a square bracket there. So you want to compare and contrast these. Compare to see what's similar. Contrast to see what the differences are. So x greater than 7, 7 less than x, or if you want x greater than 7, x greater than 7. you get your arrow going to the right because x is bigger than 7. Open dot on the 7 or parenthesis on the 7 pointing to the right. And that gives me an interval notation. Parentheses 7 infinity, always reading left to right. Infinity should always be on the right. Negative infinity is always on the left. Okay. Go with the equals. 7 is greater than or equal to, x is greater than or equal to 7. X is greater than or equal to 7. So we get solid dot at 7 because of the equals, which is the same as the square bracket. X is bigger than the 7, so you shade to the right. It can be equal because you have the solid dot. And then you just write out your interval notation, which is square bracket, 7, comma, infinity parenthesis. Now this is what we call a compound inequality. There's actually 3 inequalities here. So it says 7 is greater than x is greater than or equal to 3. You could also read that as from the x for both of them. So you'd have x is less than or equal to 7 and x is greater than or equal to 3. I don't like this order. You can flip this whole thing around and do it this way. I like this better. 3 is less than or equal to x is less than 7. Why do I like this one better? Because this one has the numbers in the order that they are on the number line. Whereas this one's backwards. See, 7 is to the left of 3, which is kind of weird. So usually if I saw this one, I would just switch it immediately to this one so that I don't make any mistakes. So then we graph 3 and 7. Make sure 3 is to the left of 7 because it is on the number line. The 3 is solid because of the equals, greater than or equal to, x greater than or equal to 3. And x less than 7, so it can't be equal to 7, so there's a hollow dot. Okay, and then these ones, this is saying x is between 3 and 7, so you shade in between. It's either between or it's 3. And if you use brackets and parentheses, it looks like that. In an interval notation, we'll get a square bracket 3, comma 7. Don't ever write 7, comma 3. These are not like points in the plane where the numbers could be switched. These are intervals on the number line, and they're always in order left to right on the number line. So the interval is just interval notation is just shorthand for the interval on the number line. Okay, x is greater than or equal, 7 is greater than or equal to x is greater than or equal to 3, or 3 less than or equal to x less than or equal to 7. What did I do? I just made them all, I put equals on all of them. So now I'll have brackets on both sides, or solid dots on both sides. 3, 7. Otherwise, it's the same. And so that interval notation will have a square bracket, 3, comma 7, close square bracket. Okay, and then other combinations of those. So make sure that you have all of these down. You understand why they are the way they are. You understand why the number on the left's on the left, why the number on the right is on the right. When do you use the square brackets? When do you use parentheses? Etc. How do the graphs relate to the intervals? You need to know all those because we use these a lot, and you don't want to get stuck on easy points like this.